Okay, welcome. Um, welcome to the stage. Thank you so much. I'm looking forward to your presentation on digitizing the additive manufacturing supply chain. Take it away.
Thank you, Lindsay. So real quick, I'll hand it over to Stephanie for an introduction.
Hi, everyone, and thanks for attending today. My name is Stephanie Gaffney, and I am the Director of Additive Manufacturing Programs at the Youngstown Business Incubator. As our name states, we are a traditional business incubator, but we do a lot of higher TRL, MRL level technology integrations into existing manufacturers. We work with very large companies, Boeing, Goodyear, all the way down to the smaller mom and pop shops to help them understand the where, when, why, and how to use additive, use it effectively. We also I sit on American Makes Executive Committee, and we are actually neighbors right across the parking lot from each other, and we do a lot of synergistic work together. So I'm here with Ashley today talking about some of the past projects we've worked on, and talking about how additive can help within the manufacturing supply chain. Thanks, Ashley.
Thank you, Stephanie. So I'm going to go ahead and kick this off. And first of all, I wanted to kind of do a little meet and greet. Why am I here? What is my story? So I'm going to jump right in that, and hopefully you guys enjoy it and get a feel for who I am and my past history. So with that, so to give you some background, as soon as I started elementary school, and all of us, were asked, what do you want to be when you grow up? And this question gets asked over and over again, all the way through high school. You could be whatever you want to be, reach for the stars, do what you love, are some of the motivational quotes that I would hear from teachers and parents. Do what I love. Okay, so as a little kid, I loved animals. So I was determined to have a career that dealt with animals. This decision was decided in elementary school, and I stuck with it. I bounced around from like veterinarian to animal ranger to marine biologist, but I stuck with animals. Well, that all changed my sophomore year of high school when my geometry teacher approached me after class and she asked me, have you ever looked at going into a career of engineering? Engineering? When my teacher suggested this field, I was in shock. Just the sound of that word to me back then sounded like a boring man's career. And why would a little redhead girl be interested in that? But man, was I interested to find out more. I did a lot of research and I saw the endless opportunities from the hundreds of engineering fields out there. How did I not know about engineering? So I started putting the pieces together. I always loved building things, whether it was Legos or Connect sets, and I loved fixing things too. So engineering seemed like a pretty perfect fit. Out of all the engineering fields, I chose industrial and systems engineering. To me, it was very unique to improve quality, efficiency, and productivity. With this field, I could get a career with practically any company I desired. Every company is looking for improvement, right? So I thought it was a great choice. So my sophomore year of college at Youngstown State University, I started doing some projects that got involved with manufacturing companies. Before this, I had no idea what manufacturing was. I was amazed. Every item in this world is manufactured. What we wear, what we use, what we touch, even what we eat is passed through these facilities. It was unbelievable. I wanted to learn more and gain experience. So I tried to attend as many manufacturing tours as possible. How did I not know about these facilities that were literally in my backyard? So I got my first internship at a company called Resner, which was an HVAC manufacturer. And I was in charge as a college intern of implementing Lean and 5S on the shop floor. It was by far my most challenging job to date. The tears I shed as the shop floor workers, they didn't want to hear anything I had to say or implement any of my ideas that would improve efficiency. Even though it was my toughest experience, it was definitely the most impactful. I learned so much during that internship. And then another class tour led me to the National Additive Manufacturing Innovation Institute, which had just opened in 2012. And I went down there to tour it in downtown Youngstown, which was a short walk from the university. And this is when I was introduced to additive manufacturing, a process to manufacture parts layer by layer. This new technology was revolutionary. I had to get involved. There was an internship opening for a workforce and education outreach intern at this National 3D Printing Center, and I applied. I was an engineering student, and I applied for a workforce and education internship. Was I even qualified? If I had known my own limitations, I would have never taken that risk. And the risks led to life-changing experiences. Through this internship, I fell in love with 3D printing, and I also met my future husband, Matt. Two things I would have never gained if I didn't take that risk and applied for that internship. Because I took that risk, I also discovered I loved to teach. So if I wouldn't have applied, I would have never found out that either. And this is just some pictures from one of my summer camps where I developed it and hosted it to teach girls in STEM about traditional and additive manufacturing in the sandcasting industry. So there's a lot more to that story, a lot more background, especially about the hometown, Youngstown, Ohio. So instead of hearing me keep rambling on, I thought I'd add a little video to this presentation. The video is called Rethinking Manufacturing, and it was produced by NIST, the National Institute of Standards and Technology. It's a documentary that summarizes how additive manufacturing has specifically impacted my hometown of Youngstown, Ohio. So let me see if I can share that with you guys. Okay, here we go. Let's see. Gotta figure out how to shut this video off now. Don't know how to close that window. But I'll just not delay and keep going. Hopefully it won't replay. So thanks for taking the time to listen a little bit about how America Makes, which is one of the Manufacturing USA institutes, has really impacted the area where I grew up. And we've experienced it and we've seen it, Stephanie and myself. And fun fact, Stephanie used to be my boss, and I've learned so much from her as well, and all the great stuff she's taught me under the Youngstown Business Incubator before I transitioned back to America Makes. So with that, so the history lesson's over. Now let's get into the nitty gritty of what Stephanie and I have been working on for the last 3 years, which is the development of a digital additive manufacturing supply chain. So what does that mean? So under this program, we wanted to develop a system that enabled bidirectional, ultra-secure digital transfer of contracting documents, technical data packages, and manufacturing process information between the government agencies, the DoD OEMs, and the industrial-based manufacturers. For those not familiar with this program, and in order to implement this digital supply chain, we needed to create functional digital connectivity between those that buy the additive manufacturing parts and those that supply them. So under the AMNOW program, we focused on the center part of the digital thread. So digital thread means a lot of things to a lot of different people, but this is how we defined it. And as you can see on this graphic, the sourcing, production, and delivery pieces, which is the center part of the supply chain, that is where we focused on. And this is where connectivity is assumed to be expensive and hard to do, and the perception that creating this piece of the digital thread will increase the price of the part. So this is what we were faced with 3 years ago. How did we combat that? We created a platform using open standards and stayed away from licensing a product. So fast forward 3 years, and the result is we created a platform that the Army has unlimited rights to, and that performs its function just like a proprietary software product would. The beauty is the investment was made by the government, and there is no need to recoup the investment from the people who are using it. So we don't need to pass those costs along. Because it's open standards based, we can interface with any system that we need to, so there is nothing really limiting us. So that is one part we accomplished under the program, and it's called the Advanced Manufacturing Intelligence Platform, AMIP for short. The other critical piece of this digital link is the edge device. We didn't want to build a new device, so we looked to commercial technologies. There are a bunch of options out there, but we wanted to look for something that didn't force the data into some proprietary structure that couldn't be dissected by the machine learning or AI suppliers that are out there. We selected the LIMS IIoT Edge device, which was a one-time $5,000 no reoccurring cost to the suppliers, which was minimal to a supplier. So there was no real cost impact to the supplier, which allowed the buyer this in situ data in order to help them with part acceptance and reduce the cost of inspections and non-destructive testing. We know from our OEM advisory board members that there is an inclination to ask for this data, but they are just reluctant because they don't want to drive up the costs. And we think we have solved this problem. So we had the AMIP platform and the IIoT Edge device that collects the in situ manufacturing process data. Now we needed to make it robust, industry grade, and a high TRL level. So how did we do this? The only way to do that was to inundate the system and supply chain with use cases that challenged all the different capabilities, different materials, different part complexities, different post-processing. So we've been exercising this platform for the last 3 years, which resulted in a various byproducts under the AM Now program. Stephanie, did you have something to add?
Nope, I'm okay. Keep going.
Okay. So in addition to developing the AIMIT platform and introducing the edge device to the suppliers, we had a lot of different byproducts that came from this program. And one of those was this, the elevation of the supply chain through a lot of supplier development. So under the AM Now program, we had a very specific region we focused on. It was Northeast Ohio and Southwest Pennsylvania. So we conducted supply chain assessments to understand the current capabilities within this region. Gaps that were identified were addressed through supplier development activities to assist in closing those gaps and elevating the supply chain. This was through webinars, on-demand learning, on-site learning. We currently have 213 suppliers registered within our platform. And under the program, we executed 119 individual funded project agreements with the supply chain in order to develop and gain real feedback from the supply chain on this creation of the digital additive manufacturing supply chain. So through the AM Now program, as we were executing these projects, the suppliers were able to learn a variety of things. One of the big gaps was how to develop a government cost proposal. So we really helped with that. We also broadened and optimized their material capabilities. We helped them efficiently manage data and improve their process controls with this edge device. And you can see some of the quotes from our suppliers below. I got to work with a lot of these suppliers over the last 3 years. So did Stephanie, and it was just amazing to see their improvement. Another piece of this puzzle was, in order to capture all this data, we also wanted to kind of look at the additive manufacturing processes as a whole and kind of build those up too. So in order to capture all this digital data, the first step we took in the program was to identify all of the operational data KPIs associated with the 7 ASTM additive manufacturing processes. So we went even a step further. Instead of just the additive manufacturing processes, we identified ways to capture data in post-processing, such as machining, surface smoothing, thermal processing, chemical finishing, testing, the list goes on and on. We identified over 1,000 data KPIs. And in order for the suppliers to capture this digital data off of the machines, we deployed those edge devices throughout the supply chain. So we put them in Northeast Ohio, Southwest Pennsylvania, and also Northern Alabama. So that edge device is that collection point of all this process data being collected. We currently have 67 edge devices deployed throughout the supply chain. So through all these projects, we produced over 2,000 parts and tested over 5,000 coupons. And this was across 28 different Army relevant use cases. So these were real use cases. We were pushing through the supply chain, funded projects, getting all this data back, looking at it, uploading it to the platform, getting it all digital, connected. So real quick, just want to show you a few of these parts. Not going to spend a lot of time on it. But here's just some of the parts we produced through this digitally connected supply chain. You'll see polymer parts, metal parts, a variety of things, tools, some end usable parts. Not going to go into detail. If anyone's interested, feel free to reach out. Wanted to get into, I talked about how we were making the additive manufacturing processes robust. we did this through 4 specific process development projects. So we were developing the AM process and the material. What we focused on was binder jet additive manufacturing for 4130 stainless steel, and then 3 other projects that focused on laser powder bed fusion, one with 316L stainless steel, another with aluminum tensile magnesium, and the last one was a high-strength aluminum called 7A77. So how does all this great process development that we were doing and conducted under the program get transitioned into industry? So we actually been working on the development of all these SAE AMS specifications you can see listed. This was a very significant byproduct achieved under the program. So we'll have around 10 AMS specifications released that were led by the AMNL program, and a few others that were supported specifications. And one last byproduct of the program was this ability to visualize the supply chain, which is so crucial, especially to the buyer. So whether it's the Army or an OEM, whoever you're visualizing the supply chain through. So this platform that we developed, in order for a supplier to participate, they had to fill out a supplier profile and get registered with our platform. So we were capturing information, very detailed information regarding capabilities, build materials, machines, certifications. And because we were capturing all this, we made it a visualization capability. You can go into this map that you see in the bottom left corner, where you can go into the supply chain. You can click on those suppliers. You can go into their supplier capabilities. You can filter based on all these different facets to look for different suppliers. And not only does the buyer have that ability, but all the suppliers also have that ability to look at their supply chain, connect with people, visualize it, and really bridge all those gaps. Lastly, just real quick, I mentioned we had 213 suppliers who registered in the platform. This kind of breaks down those suppliers based on their supply chain role. You can see, in addition to additive manufacturing, we had suppliers who were post-processing, designers, test houses. And then the graph on the right breaks down what types of additive manufacturing processes the suppliers conducted. So we had a really nice spread of all of that. So I know we're behind, so I rushed through all that. I could spend another 3 hours on the AMNOW program. We just did so many different things. I could spend an hour on TDPs, an hour on process development, an hour on supply chain development, an hour on the edge device, an hour on the platform. So if anyone's interested in any of those things, please feel free to reach out. We can go a lot deeper into any of those items, but I do want to just end with, it wasn't me. It wasn't just NCDMM. It wasn't just me and Stephanie. We had a great project team. I'm sure a lot of these people are on the conference as well, that put all this together. Supplier development people, supplier outreach, our software developer, our Lex Energy, who did the LIMS device. Just a great team. So I just want to thank them and make sure that they're represented. So with that, Stephanie, do you have anything to add?
No, that sums up the project. The Army has, found the project to be very successful. We are looking at other opportunities for follow-on funding, and to take this little area and this test bed and to deploy it, across the U.S. into more regions as well.
Yes, very important. Yeah, thanks, Stephanie. And last slide is just a shout out. I'm ambassador for the Youngstown, Ohio chapter of Women in 3D Printing. So if anyone who's listening in is in that region, please feel free to go on HiveBright, join my chapter, and here's some pictures of our previous events. We have a lot of fun. So just a little shout out there.
That is so great. Thank you so much, Ashley and Stephanie. That was an incredible presentation, a great way to end this block.